Hello everyone, my name is Anthony Shivkumar, and in today's video I am going to basically retry creating and working with the brushless DC motor. I bought the NXP brushless DC motor because they kept saying that if there was something wrong with my motor, so I just thought, let me buy the original NXP's brushless DC motor with the actual Freedom board, because my objective is also to understand the algorithms that they provided. And if I can debug more on the software side of things, I don't have to waste time on figuring out whether it's a motor problem or not, because I can spend more time on the software. So what we have over here is the it's the Freedom MC LV meter, so LVMTR, and let me try and open it. So here we have the motor, and just to give in context where this is coming from, this is the thing that I'm using. So this is the motor that I bought, which goes with the board that we have in here. So this is for the three-phase brushless DC motor control, and we'll try to see if everything works. All right, so I've set up this whole thing as we see over here. Okay, so what we have here are the three wires. So this would be phase A, phase B, phase C, and the others would be for the Hall effect sensor connection, and that will be connected on this part of the brushless DC motor board. And I don't have this connection. This is mostly for Hall effect sensor, if I'm not mistaken. So what I'll do is I'm going to connect the three phases right now, and then we'll see where to go from here. So I need to make sure that these connections do not touch each other. So I'm making sure that they're far away apart. And here we have, I'm just going to connect the power source. And before that, let's go and check the software. So yeah, this is one of the connections that we have over here, and I'm just trying to basically, make it look very similar. And this is the Hall effect connection on the right, which I don't have this connection, so we'll try to do without it. And here, let's get the software. So one of the things that I had mentioned in the NXP support channel, and what did they tell me? They told me that I would need, in order to use the FRDM-MC motor control brushless DC example, you need to use SDK version 2.90. So how do I get it? So when you go to NXP over here, you can click import SDK examples. And in order for you to get the SDK 2.9, you can click on this particular icon over here. So as of this recording, I am using MCU Expresso. I believe it's 11.5. So by the time you watch it, it might be a different version. So you can click on install MCU, install the plugins. And here I just did the KV31. And when you go to FRDM-KV31, this is the board that I'm using. Just basically you want to install a particular driver. So I was looking for the motor driver, or you can actually go to the processor and then click KV31. And here what it shows you is all the latest 2.12. So just untick the show latest, and then you can get the 2.9 as recommended by the NXP support channel. Because 2.9 has the brushless DC motor driver. The latest version does not have it. So don't ask me why, but that's what it is. I've already gone and installed it. As you can see, it's highlighted over here. So there's a 2.12 that I've installed, and the 2.9 as well. Yeah, so the 2.9, which is not highlighted because I've already downloaded. So I can only uninstall. So you can download the 2.9 version if you want. And once you download the 2.9 version, I have the FRDM-KV31 MC brushless DC motor right here in my McuXpresso. So this takes care of the FRDM-KV31. It's a brushless DC motor driver, and this should work. Apparently, this should work with the configuration and the setup that I have right now. So what I'm going to do is I'm going to build this. I've already built this. I've already downloaded the code, but I can do it again. So you're installing the FRDM-KV31 motor control brushless DC motor driver. Now, just to make sure that what this code is doing. So in my opinion, I'm not really gone through the code in detail, but I do believe this is the sensorless brushless DC motor driver. So we don't need to necessarily connect the all sensor. This is the commutation sector. So it's basically, it should be able to work without the Hall effect sensor. Rather, it should work sensor using a sensorless mode. It doesn't say in the comments, it doesn't really explain whether it is sensorless or not, but I don't think it is a censored. It requires the Hall effect sensor to be activated. Okay, so once we have this, then you can go and put that out here. So for me, what I would have to do is now connect my USB. Now I've connected my USB. It is flashing green over here, or red over here. If I cover the angle over here on the light, you can see it's flashing red over here. So I've already installed the software, but we will install the software again. And it's flashing red over here, basically saying that the voltage threshold required to operate this whole setup is not met. So as we are in the error state. Once I increase the voltage to 10 volts or 12 volts, then it will start to be just red, it won't be flashing. So let me show you, let me download the code. So as soon as I install, it says the FRDM-KV31 board, and then I can click search again, and it's found the OpenSDA thing. So I'm just going to basically install the FRDM-KV31 MCV board. What I'm going to do is try to put this on here, and I'm just going to click run. And here you can see it was flashing a little bit. And now it's all done. It's all installed. And let's now try to make it running. Okay. So one thing to do is I've got to restart this whole system, and now again you can see that this is red over here. I put my voltage probe over here, so we'll see what the voltage is. Now this is 10 volts, and now you can see that that over here that this the LED is now stopped running. So now I'm at 10 volts. Let's see what the recommended voltage is. So this shouldn't start to spin immediately because I'm not activated it. So we can see it's 10 volts. Let me see whether I need to be at 10 volts or not. So here he says supply properly with 10 volts around 5 amps. So my power supply can definitely handle 5 amps of DC current. And right now we're doing it at 10 volts. So I'll put it at 12 just to make sure everything is fine. So right now the probes are now connected to 10 volts. I'm going to bring it up to 12 volts. There we go. So it's around 12 volts over here. This is connected to 12 volts. And I'm already installed the motor driver software. I don't know what to expect, but let's see. Yep, and it works, and it started to rotate. So great, it works. So let's try it again. So I'm going to basically try this again, and it's rotating. It's basically driving 12 volts. It is rotating. You can see over here it's spinning, and there I've stopped it. So it does take a little while to activate. It's, I think it's basically trying to create the pattern. As soon as I stop it, it stops. But as soon as I try to enable it, when it turns to green, you'll realize that it slips a little bit. It's trying to basically find the right commutation sequence, and then it starts to spin. So it gets stuck, and now it starts to spin. So gets stuck, and then it starts to spin. Gets stuck, and then it starts to spin. And now it's green over here. And here we have it. So it's constantly trying to. Now it's spinning quite. It stops, and then it spins. And that's, I think, the algorithm which basically goes at high speed, then it slows to go slow speed, and then it goes to high speed, it goes to low speed. So let's have a look at the algorithm to make sense of what's really happening. I'm going to stop it right now, and we'll get back to why is it going high and low and high and low. So the algorithm itself, we have our main loop. We're disabling all the interrupts. Pause action demo. So we're pausing everything. We're initializing the board. This is the initializing peripheral motor driver for motor M1. Let's have a look at what it's initializing. You should mostly initialize the clock, the peripheral ADC converter, the timer. Timer might be for commutation. The other one might be for PWM. So we initialize the timers, and then we initialize the PWM. Let's go back. And then we basically initialize the system clock or the system tick. M1, turn off the application, enable global interrupt. So in here we have the ADC interrupt handler. And here we have the timer interrupt handler. So this timer 1 and timer 2, this is fast timer or flex timer. This is the force. This particular timer controls the commutation. Second one, I'm not too sure. FTM2 reloads the interrupt service routine called with the 1 millisecond period and processes following functions. Okay, so here we go. So if I is LED red toggle, LED green off. If in false state, red blinking. If it's in run, then we turn on green. So I'm not too sure. I mean, this is doing some state switch. And here we go. Process only if processing longer than timeout. So this is the port A interrupt. I'm not too sure. Okay, port A interrupt. I'm not too sure what port A is connected to. So now this is the demo speed simulator. When demo mode is enabled, it changes the required speed according to predefined profile. So this is why we have the goes high and then it goes low. So if it's in demo mode, then we have case 1, it's M1 set speed, M1 set speed. So we have the different cases over here. And let's see who's calling the demo mode simulator. The demo mode simulator is with the interrupt 2, and it's not. So we go over here, depending on the increase push button press counter, increases push button press counter. So this will constantly increase to 1. It'll increase to 1000 basically, or reduce to 1000. And once you reduce this to 1000, then we increase the switch. And then it goes from switch will basically go from 1000 to 2000, and then it goes slower. So yeah, this is the way the speed is basically after every 1000. So basically every 1 second will basically move to another speed, and every 1 second will move to another speed, and then it'll go high, and then it'll go low, and then it'll stop. This is where the speed control is coming from. And yeah, so if you want this to, the high speed is I think 1500 RPM, assuming this is RPM, I could be wrong. Let's see what this function does. So M1 set speed, so we get the speed command, set speed, and here we're initializing the speed, setting the control BLDC, else set 0 speed. So if you have a speed, I think it'll set it in RPM. So here we're looking at a speed of 1000 RPM, 2000 RPM, 1500 RPM, 1000 RPM, and minus 2000 RPM. I'm not too sure if it reverses, but we can try again. So put this like this and see if we can see, and then I'm just going to basically do the green button over here. It runs high, 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 then it goes slow, and then it'll eventually stop. Stopped, and now again, right? So everything is working based on the demo application, and this is the brushless DC motor controller. So I add in a little bit of load. It does let's add in the thermal camera and see how much heat this whole thing is generating. So while the motor is spinning, I'm going to bring in my thermal camera, and then we'll see how much of the heat this is generating. We'll keep it running for a little while. We've got it at 12 volts. You can see that there's a voltage drop as well as soon as it tries to activate it from 0 to so and so. So it's clearly having a hard time. So it goes below, and then it. So here we have a thermal camera, and let me put this all over the board over here. You get a sense that, to put this way, rather. And overall, it's pretty low in temperatures. 31 degrees. There's nothing heating up. Looks pretty good to me. The main chip, I think, is getting heated up a little bit, but for the most part, it's not really getting heated up. So 31 degrees is the range. So the board over here is around 29 degrees. So yeah, I think it's working in pretty optimal condition, and the board is not heating up. The MOSFETs are switching properly, and it's rotated. It's 31 degrees is pretty much room temperature, or a little higher than room temperature over here. All right, so that's it for me. The algorithm works. I can work around with the software a little bit more. I've been running this for a little while right now. As you can see, each time it's activating, there is a voltage drop. But other than that, the algorithm works. Yeah, so thank you.